Hi guys, welcome back to Data Every Day. Today we're looking at a data set of daily power generation in India. We're going to be using this file, file02.csv, which basically has a bunch of different daily power generation reports from various regions in India. And we're going to try to use the numbers to predict what region this report is coming from. And we're going to use 8 different models to make our predictions. So here in the notebook I have some imports that we're going to use. NumPy and pandas just with working with the data. We have the label encoder, standard scaler, and train test split function from sklearn, mainly for pre-processing. And then we have our models. And these are, we have 8 models. 4 of them are standard algorithms: logistic regression, support vector classifier, multi-layer perceptron classifier, and decision tree classifier. And the other 4 are ensemble methods, which combine models in various ways. And we're going to use the confusion matrix to get some insight about our data. So, about our results, I should say. So let's get started. I'm going to load in the data using pandas.readcsv. And I can get the file path right over here. Remember, we're using file02.csv, so I copy that, paste it in, and I didn't actually import it. Okay, paste it in, and I'll take a look. And so we have about 5,000 examples and 9 columns. And we're going to try to predict the region based on all the rest of the data. So the first thing I like to do when dealing with a new data set is we'll just look at some info so we can get a general sense of the data types and the null values. We can see it looks like we have some null values in an identical number, but just in these 2 columns. Additionally, there are objects stored in these ones. For date and region, that makes sense, but for these 2, yeah, it appears that thermal generation actual and thermal generation estimated are stored as objects. And I think if we look up, we can see why that is. There's actually commas in there, so we're going to have to make sure to remove the commas. Also, the null values in these 2, these are stored as floats, so that makes our lives easier. We can just fill them in without worrying about commas. So from the looks of it, what we have to do is fill in null values for the nuclear columns, remove the commas from the thermal columns, encode the date column in a way that makes more sense, and encode our region labels as labels from 0 through, I believe there are 5 different regions. Yeah, 5 unique values, so it will be 0 through 4 in our region column. Okay, so let's start pre-processing. First thing to do, I should also say, we're going to drop this index column because that's not giving us useful information. So dropping index column slash checking missing values. Okay, so we'll quickly drop that column. Data equals data.drop index axis 1, just so we don't have to worry about it anymore. And then for the we want to just take a look at the missing values. So data.isNA gives us the data frame, but with a true or false for each value if it's missing or not. You can see we have a true there. That's because there's an NaN here. So we're going to sum across. This will we're summing across the rows, so summing down. We'll add up all the trues and return the value for each column. Basically, how many missing values are in each column. And like it is like a sort of the complement of up here. You can see there's 1,978 missing values in both of the nuclear columns, which we want to fill in. So how do we do that? Well, let's take a look how much of the column is this. So if we do sum, we just get this flat amount, but we sort of want to understand like what percentage of the column is missing. So instead of sum, we can do mean, which if you think about it is just adding up all the trues, which is this number, and then dividing by the total number of examples, which is the number of rows. And so this will be the percentage. This is saying 40% of the examples in the nuclear generation, actual and estimated, are missing. And so 40% is a pretty substantial amount. However, so what I mean is it's not small enough that we can just drop the rows. And we may never actually want to drop the rows. It's usually better, especially if we're dealing with a numerical column like this, we can fill these in with some value that makes sense. And that could be the mean, the mode, median. It could be, or you could also use some more advanced techniques to impute the value. But I think we'll use the mean. So all we have to do, how do I do this? For a column in, so nuclear generation actual in MU is one column, and then the same thing, but it's estimated, right? For a column in these two, data subcolumn equals data subcolumn dot fill in a. So fill in a function will fill the missing values with a given value, and the value we want to fill with is data subcolumn dot mean. And I just did it in a for loop here so that I don't have to write out the column name each time. Run that. If we take a look at the missing values again, this time if I sum across the rows like before and then I sum again across the columns, we'll get a total number of missing values. So I'll print total missing values 0. We're completely done with the missing values. So fantastic. We do have a large amount of sort of I wouldn't say, I don't know, fabricated data. It's data that is generated from the other examples. However, it's only in 2 columns, and we're going to hope that we can still have enough information from the other columns to make up for those 40% of the examples that have imputed values. Okay, so let's create year and month columns. So, what do I mean? Let's take a look at data again. Right now we have this date column, and right now it's not of much use to us. This isn't actually a numerical value. What we could do is sort these in terms of in chronological order and use it as an ordinal variable. But what I think is much more effective is if you create 2 new features, one called year and one called month, and you just strip out the year and month from the column. This is because the year gives a good sense of recency or chronology, but the month tells something about a cycle, about the cycle of time. High value of month usually means it was very cold at that time if you're in the northern hemisphere, and a low value of month also means cold, but values in the middle usually mean very warm, because it's during the summer. So I'm going to take date and apply a lambda function to it that will just take for every x, which will be one of these, we're going to return the first 4 characters of x, which will just be the year. And then similarly for month, we'll do the same thing, but index it from 5 through 7. That will just be the month, just this. So when we're done with that, we can drop the original date column and see what we get. Data.drop. So let me just run this line. Okay. So take another look. You can see we now have the year and month column at the end, stripped from the original one, and the original date column is no longer there. So now the only thing is these commas, right? We know there's commas in these columns that we have to remove. So why don't we do that? We'll say removing commas from thermal columns. So data sub, I'm just going to grab this. Here, what do I do this? I'll grab this for loop I had before, and instead of doing this, well, I'm going to replace this with thermal and thermal, so that now we're just dealing with these. We're going to say data subcolumn dot apply lambda, takes some x and returns x dot replace comma with empty string. So these are already strings. We know because when we check the info, it says they're objects right here, this one and this one. So we can use .replace to replace a substring with an empty string. So anytime it finds a comma, we can replace it. And then after that, we're going to turn it back into a float. So now it's going to take our x, which will be one of these, and if it has a comma, it's going to replace it with nothing and turn it into a float after that. And if we run this, if we look at data now, the commas are actually still there. Oh, I know why. I didn't actually set them. Okay. Now the commas are gone. And they're also floats. If we look at the D types, you can see everything is numerical except for region, year, and month. And these should be integers, right? So the reason for this is I didn't actually turn them into integers up here. Let me just do that really quick. And I'll rerun the notebook. So if I run it now, all the way through, you can see everything is now in integer or float format except for region. And region is very simple. So encoding labels. For this, we're just going to use sklearn's label encoder. So label encoder is going to be a new label encoder object, and all we have to do is say data sub region equals label encoder dot fit transform data sub region. All right, and that will turn. If we here, let's put the D types down here. Now you'll see there is an integer form, and if we look at the data, this is now values of 0 through 4 for each of the 5 regions. And now we're ready to get our data ready for training. So that entails splitting and scaling the data. So for splitting, I mean let's separate what we're trying to predict, which is region, from the rest of the data that we're going to use to predict it. So y will be what we're trying to predict, data sub region, and we're going to make a deep copy of it. And x is going to be everything except region, so we're going to drop it from axis 1 and make a copy of that. And now we're going to scale x. And what I mean by scale is we're going to take each column and shift and scale the data so that each column has a mean of 0 and a unit variance, so that all of the columns take on a similar range of values. And this makes it much easier for our models to deal with the information. So I'm going to create this standard scalar object from sklearn called scalar, and then x is going to be scalar.fit transform x. Simple as that. You'll see x is now a NumPy array, but all the values are scaled between so that most of the values are going to lie between -1 and 1. Alright, and then we just want to split it one more time into train and test sets. So we want to do this randomly. Well, we will use the train test split function from sklearn. So I'm splitting x and y into xtrain, xtest, ytrain, ytest, and use train test split, passing in x and y, and we'll specify a train size of 70%. And now you can see that we have taken only the 70% of the data, which is 70% of 4,945, gives us 3,461. So we now have a train set with the same number of features. Similarly, the test set should only contain 30% of the data. There it is. Okay, so now modeling and training. So now let's set up our models. Now we have 8 different models today, and we're going to compare the performances of them. So I'm going to store them all in a list. And you can see at the top all of these ones I imported. I'm just going to create a list of new instances of each one. And just for the sake of time, I'll just copy and paste that in. So I already went through and created this list with 8 different models from each one we imported. Additionally, I'm going to create model names. That will be a list of 8 characters, 8 names, one for each model. And I'll just paste that in as well. It's just they correspond element by element, you can see. These last four are the ensemble methods. Okay, so let's run that. We now have some models and some names, and we're going to get the results for each one. So I'm going to create results, which is just an empty list, and I'm going to say for I in range length of models, so essentially for each model indexed at I, model sub I dot fit x train y train. So we're gonna fit each of the models on our train set, and then we're gonna append model sub I dot score x test y test to results. So we're going to fit it on the train set and get the accuracy score on the test set, and then append that to results. So at the end, results will have 8 different accuracy values. Okay, run that, and let's check the results. So, okay, I realize we're actually not going to use the confusion matrix today, just because we have 8 different models. I don't want to create 8 different confusion matrices, but I'll definitely include it in some other videos. But essentially, let's just print out the results from each model. So for I in range length of models, so we're iterating through again. This time print model names sub I. So this is going to be the name that corresponds, and you can see I indented them so that they all line up, and we can see the accuracy values side by side. And then we're going to concatenate a colon, a space, and then we're going to put a formatted string in here. So we're going to format result sub I, and so that it has 4 decimal places. Alright, and there we go. We can see that our models performed very well. 99% accuracy on almost every model. The neural network seems to have taken the lead with a 99.93%. And we can even bump this up to 5 decimal places so we can see. But yeah, neural network seems really good. Support vector is in second. Actually, it's tied with the bagging classifier and random forest. Interesting to see that AdaBoost did very poorly compared to the other models. It's the only one that really dropped the ball. But all in all of these seem to be very good models, and it doesn't seem like the ensemble models were really necessary. It seems like they did just about as well as the individual models, and the neural network beat everything. Alright, so that'll wrap up today's video. Thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.